Okay, before I start recording this video, it's quite important for me to announce that I'll only be making videos for the computer science periodics, not for the AMSs, nor will I be doing videos for the finals. Also, another thing, when studying for any computer science exams, I suggest not using your calculator to get used to the atmosphere you'll be in during the actual finals. Okay, first question. What are the tasks of the arithmetic logic unit? To put simply, the ALU, or the arithmetic logic unit, it does all the math, all of the logical operations. Yeah, that's pretty much it. Okay, next question. Storage refers to remote location servers online rather than on the computer system. This one is cloud. Cloud storage refers to remote locations on servers. There's really no explanation to this. Mary wants to write her resume on Microsoft Word. She uses a keyboard to type and the mouse to move the cursor around. Which category of devices do the keyboard and mouse belong to? Once again, this is a pretty simple question, input devices. This question you might need. This question might cause a bit of struggle. Most mobile phones use touchscreens. Mobile phone manufacturers commonly use resistive, infrared, and capacitive technologies. Or capacitive. Which of the following is not a feature of the resistive technology? Okay, this is basically what resistive touchscreen is. A piece of glass with a conductive underside, and underneath this conductive side there's another piece of glass with with conductive side. When the user presses, let's say this is the finger, or anything for that matter, because this type of touchscreen allows for any type of thing to press it and it will work. The way this works is once the finger or the user pushes down on the screen, it will cause this whole thing to move down, causing the conductive layers to make contact with one another. And once this conductive layer makes contact, it registers a press. However, the problem is with this type of touchscreen is it's usually has low brightness when outside. Now, knowing this, we go back to the question, which of the following is not a feature of resistive technology? And simply, it's using no touchscreen uses solar cells. Infrared touchscreens are something similar as to what's depicted here, though usually they're much closer to one another to be more accurate. So how they work is basically, let's say the user presses, how they work is usually, let's say the user presses somewhere around here. This will cause a disturbance, which will send signals to sensors, and which will then allow to register a tap. Issue with these types of touchscreens is they're usually very expensive. Okay, now we know this. What are the characteristics of the infrared touchscreen? Like I said, it was expensive. It's the screen detects where was touched and the beams were interrupted. Okay, next question. Which of the following statements is false regarding HDD? HDD is basically like this little thing, or not, it's not really little, but inside it there's this disk that rotates at high speeds, and it can be read by electromagnetic heads. So which of the following statements is false? Usually does not have small. Usually they have these types of storage devices, especially secondary storage, have large amounts of storage capacity. What are the disadvantages of cloud storage? As said in the previous question, cloud storage basically storage outside of the computer held on servers. Now we're looking for disadvantages of this. Is it possible to access data saved on cloud storage if there is unstable internet connection? Obviously not. It's on servers, not on your computer. You'd have to have a network connection to be able to connect to those servers. Saved data on the cloud can be accessed by any user with an internet connection. This is true, but this is not a disadvantage. There is a risk of being hacked. With anything on the internet nowadays, there is a risk of being hacked, no matter the type of security enforced. Cloud data are compressed with lossy compression, thus losing the quality and content of saved data. This isn't true, because you wouldn't want to lose data. Relying on the online storage company which is responsible for cloud storage to maintain the security of the data can pose security risks. This ties in with this one. So yeah, what is the new binary value if we apply two logical right shifts on the below binary number? What we're being asked of in this question is to apply two logical right shifts. To do this, all we really need to do is move each bit to the right twice. So this means here 0, 0, 1, 1, 0, 1. Right now we have 6 bits. To complete this, we need to add 2 more zeros at the end to make it the full 8 bits, which is usually required from us. Which means this is the correct answer. What is the binary form of the below 2's complement? So we're given an 8-bit number that's 2's complement. And you know in 2's complement, the leftmost bit is signed, aka it's negative. When dealing with these types of questions, you just add any activated bit, which is negative 128, 32, 16, 8, and 2. Then you just practically add all of them up. 128 plus 32 plus 16 plus 8 plus 2. Add these two, you get 10. Add these two, you get 48. And this negative 128, this gives you 58, which gives you the answer negative 70. Therefore, we choose this one. This is the binary equivalence of the hexadecimal number C5. There are two different ways to go about doing this question. You can either convert C into the proper number, convert 5 into the proper number, so C would become 12, 5 would stay 5, then you convert 12 to binary on its own, and 5 to binary on its own. Or you can just memorize. Let's say you decide to do the conversion method. You take C is equal to 12. Then in 4 bits, you have to represent 12 in 4 bits. 8, 4, 2, and 1. Which is practically this. Now we can also work by process of elimination to make this simpler. So we take out anything that does not have 1, 1, 0, 0 at the beginning, which is this and this, which leaves us with this, this, and this. Now to convert 5 into binary, it's practically just 0, 1, 0, 1, which finally gives us the answer of 1, 1, 0, 0, 0, 1, 0, 1. All of the following is true about lossless compression. Lossless compression is basically the compression of files without losing its data, aka it will use algorithms to simplify this data without losing it. It is indeed used to maintain an original copy of the file, and it does not remove considerable details from the file being compressed. Repeated patterns within the original file are indexed and replaced with numerical values. This is true, and it can be used to compress all types of files. And it does allow the restoration of the properties and details of the original file. Therefore, this is false. One of the technology used to create a touchscreen is capacitive technology. Which of the following is a disadvantage of using capacitive technology? How capacitive touchscreens usually work is they emit an electric field. And once this electric field is interrupted by usually the user's finger, this will cause an interruption in the field. And due to this interruption, this will register a tap. The important thing to note about this is it usually mainly consists of glass. Then going back to this, it said we want to find the disadvantage of using capacitive technology. The glass screen is more likely to break or crack. The screen however, the screen is reliable, and it has high visibility in direct sunlight, but not that high when compared to infrared. The screen is not that hard to clean, and the screen is not cheap to create. Is in between. It's moderate in price. Which of the following is not involved in the checking a biometric password? There's a lot of steps when checking biometric password, but all you really need to know is this. Let's say a fingerprint. Let's just assume this is a fingerprint. A sensor would detect this fingerprint. This sensor then sends this reading to an analog digital converter, or to put simply ADC. This ADC will then be sent to a microprocessor, which we'll call it MP. What the microprocessor will do is check if this fingerprint is in a database. If it is in the database, then what it will do is send a signal through a digital to analog converter, or a DAC, to a screen, like let's say to a screen that says accepted. However, let us say this fingerprint does not belong in the database. It will then send this microprocessor will then send a signal to through the DAC and say that this person is not in the company or whatever. Knowing this, how we can solve this question? A sensor is used to capture the biometric password. A sensor was used. The microprocessor checks the biometric reading. It does. A digital converts the biometric reading to a format the microprocessor will understand. There is a problem with this. This is the incorrect statement, and here's why. We said that it's analog to digital, not digital to analog. Digital to analog is for the microprocessor to send it to any actuators. Analog to digital is for sensors to send to the microprocessor, which is why this is wrong. But just in case, let's continue. And the reading from the sensor is converted into digital format. It is via the analog to digital converter. The reading from the sensor is compared against the stored value to check if the biometric password is correct. This is what happens in a microprocessor. Which of the following is true about laser and inkjet printers? To put simply, laser printers use like powdered ink drums. So we want to find the true statement about both laser and ink printers. Cartridges of inkjet printers last less time than laser printers. This I just said. This is true, but let's continue. Laser printers use thermal bubble technology while inkjet printers use a printing drum. This is false. It's the other way around. Laser printers use printing drums, meanwhile inkjet printers use thermal bubble technology. An inkjet printer works faster than a laser printer. This is once again false. A laser printer sprays tiny drops of ink on paper. This is also false. An inkjet printer does that. An inkjet printer is used when many pages need to be printed. This is also false. Laser printers are used when many pages need to be printed. What is the difference between RAM and ROM, or RAM and ROM? If you don't know, RAM is basically random access memory. It's used as a temporary storage medium for the processor. And ROM contains data which allows the system to operate. Basically, is what allows your computer to work. Knowing this, let us check the options. RAM stores data permanently and ROM stores it temporarily. This is false, as if ROM were to store data temporarily, you'd constantly have to update the code in your ROM just so your computer can open. When the computer is turned off, the content of the RAM is deleted while the content of the ROM remains the same. This is indeed true. Since RAM is volatile, which will also answer this one, anything that's stored in the RAM once the computer is turned off is deleted. However, content in the ROM is important. It's imperial for any content in the ROM to stay in the ROM, or else the computer won't turn on. RAM is hardware while ROM is software. This is false. Both are hardware. And this one we already answered. RAM has a smaller capacity than ROM. This is false, and ROM only usually contains a few lines of code when compared to RAM. Your RAM is usually 32 gigabytes or gigabits or gigabytes or whatever. All of the following is true about compact discs, except how CDs basically work is a laser is shown onto the disc, and on the discs there are tiny pits, or microscopic pits and microscopic lands. When the laser is shown into the pits, it will cause the light to diffuse. Thus, when the laser is shown back into the sensor, it will represent a 0. However, on lands, due to the reflection of light, it will reflect back, registering it as a 1. The CD drive changes reflections from the CD into binary values. This is true. CDs have pits and lands that represent stored data. This is once again true. Laser beams are used to store data on CDs. Yes, this is true. Pits and lands represent information as decimal values. Important thing to note on this question: any data that's a computer is meant to understand is always, or usually stored in binary value. So this is wrong. Laser beams are used to represent data from CDs. Yes. Or read data. Laser beams are used to read data from CDs. Yes, this is true. All of the following true about a solid state drive. Solid state drive is basically, it uses a bunch of switches inside, like millions and millions of switches inside of it, or what's basically called as flash memory. So knowing this, we can continue. It stores data using flash memory. I just said this is true. It has reduced latency, aka it is very fast. Yes, the solid state drive is usually very fast. It is usually very small in size. The SSD is usually very small in size. It has no moving parts. The SSD does indeed have no moving parts. It's basically just mini switches, aka transistors. It is much slower than other storage devices. This choice you can use logic on. Knowing that HDDs are disks that need to be rotated. Let's just say this is the disk inside the HDD. However, in solid state drive, it's just a bunch of levers. Let's just say something like this. And just this over and over again. There is no moving part, therefore it's more likely to be faster than something that has to constantly move. Therefore, this is false. All of the following is correct about the MAC address, except it does not stand for the multimedia address command. It stands for the media access control address. A MAC address is used to identify devices connected to a network uniquely. More specifically, identify network interface cards, because each network interface card has to have a specific one. Or this I just answered. A MAC address is indeed unique for each device, and it is stored in a 12-digit hexadecimal number or 48-bit long number. All of the following are true about an IP address. They are indeed stored in IPv4 or IPv6. However, two computers in the same country cannot have the same IP address. Let us say these two people have the same IP address. Let's say this one is 1.179.0.255. Let us say this is his IP address. This person also has the same IP address. But let's say a signal is sent to this IP address, this specific IP address. So it will, since these two have the same IP address, data won't be able to be sent from It helps. Every computer connected to a network must have an IP address. This is true, and it also allows computers to be identified from one another. It is also called the Internet Protocol address. Which of the following are examples of embedded systems? So in a calculator, let's say the sensor would be a touch sensor, as in the buttons. These sensor signals are then converted via analog to digital. They're sent to microprocessors. This microprocessor does certain things depending on the thing itself, and yeah, it does all the rest of the work. Central heating systems are, yes, they need. Same with digital watches and lighting systems. Digital watches, they may use a touch sensor. All of the following are correct about the stages in the von Neumann architecture to execute the cycle, except first you need to know a bit of von Neumann architecture to understand. First, the next instruction is always stored in the program counter or the PC. The address stored in the PC is then carried on to the MAR. Once this process occurs, the PC is incremented by 1 to point to the next instruction. So, with what I just said, you can say this is false because, and this will be explained later on as I continue with the explanation. But okay, once the address is copied into the MAR, there's a signal sent to that address. Whatever that is in that address will be sent to the MDR, or the memory data register. Once this is done, anything in the MDR will then be sent to the CIR, and it will execute this command. And that's pretty much it. There's more in details, but I suggest checking the book. What are the main components of the CPU? The control unit, the ALU, system clock, and registers. That's all there really is to it. Memorization. Select the correct binary value for the binary value 67. There are two ways you can go about doing this question. You can either constantly divide by 2 until you reach a number until you reach a remainder 1 or 0, and you can no longer divide it by 2, or do the subtractive method. I personally use the subtractive method, but I'll be doing both. But first, I'll start off with the subtractive method. We're given the binary value of 67, so let's write 67 as base 10. We want to find it as base 2. You just need to write out the powers of 2, which is usually 1, 2, 8, and decreasing. Now that we have this written down, we can start doing the subtractive method. 1, 2, 8 is too large to be subtracted from 67, so we'll move on to the next one, and we'll add a 0 here. 64 can perfectly be subtracted from 67. This will retrieve 3 and 32, and you just continue subtracting. Can you subtract 32 from 3? No. Same goes with 16, 8, and 4, leaving us with just 2 and 1. And adding all the zeros, we get the 8-bit binary number 0, 1, 0, 0, 0, 0, 1, 1. Or this one. But let's say you want to use the division method. We take 67 and draw this little thing. What number can be multiplied by 2 to get the closest thing to 67? 33. As 33 times 2, that's 66. So do some subtraction, we get 1. Then we just continue until we get a number that we can no longer divide by 2. What's a number multiplied by 2 gets us close to 33, and 16. 32, we get 1. Divide by 2 again, we get 8. 16, 0. Divide by 2 again, 4, 8, 0. Divide by 2 again here, and you can basically repeat this process until you can no longer divide by 2. Once again, divide by 2, 1. Now we can no longer divide by 2. Then what we do is, starting from this side, we start writing numbers from right to left. Starting from this side, we start writing numbers from right to left. So 1, 1, 0, 0, 0, 0, 1, which gives us the same answer as before. Which of the following is an input device, which is an electronic virtual whiteboard that connects to a computer that acts as both an input and an output device? This you can basically get from the question: interactive whiteboards, virtual whiteboard. Simple, call it a day. Move on to the next question. Which of the following is an input device that is used to convert hard copy images or documents into a digital format that can be stored on a computer? This one is also just memorization and recognition. 2D scanner. Which of the following is an input device that is a 2D scanner that reads QR codes? This one you do need to know what QR code stands for, and it stands for Quick Response Code Scanner. So, Quick Response Code Scanner. Which of the following is an output device that uses a laser to cut material into 2-dimensional flat surfaces? Keyword here is cutting and 2-dimensional. There's only one thing that satisfies this, and it's the 2D cutter. Which of the following is not an advantage of using sensors for collecting data? Sensors do need a power source to operate. Unlike humans, there's no real power source needed to power us and to take data. So this would be a disadvantage when compared to humans. Using sensors, a computer system can respond faster to changes in the environment. This is true. When you have sensors, you can automate the process, so therefore it's going to be faster. They also do provide more accurate data. And they also are more reliable, and they collect data more frequently. Which of the following is not a characteristic of secondary storage devices? Secondary storage devices are basically the permanent storage. The thing that, think of it as your hard disk drive or your solid state drive or whatever. it is indeed not accessed directly by the CPU because it's too big and it would take time, which is why we have the RAM. It is, however, also non-volatile and permanently stores data. As I said, while running the program, the computer may use the secondary storage devices when the primary storage is full. This is true. Sometimes when you run out of space in your RAM, the CPU might decide to take might allocate some of the secondary storage as primary storage. It is directly accessed by the CPU and is connected to its data it's directly accessed by the CPU and is connected to it using the data cables and memory buses. This is false, as directly connecting the CPU to the secondary storage devices is inefficient. And yeah, they do include these two. Secondary storage devices do include hard disk drives and solid state drives. This one is basically just simple addition. Before continuing on, you need to know that there's like 4 rules to addition in binary. 0 plus 0 is obviously equal to 0. 1 plus 0 or 0 plus 1 is equal to 1. 1 plus 1 is equal to 1, 0. And finally, 1 plus 1 plus 1 equals to 1, 1. And please do not read this as 10 or 11. Knowing this, you can just continue. 1 plus 1, as we said, this is 1, 0. 0 here, bring the 1 up there. 1 plus 0, which is this rule basically, which is 1. This one, this rule, 1. 1 plus 1, 0, 1, 0. Bring this one up there. We now have this, and you just continue this pattern until you add up all of the digits, which should give you 0, 1, 0, 1, 0, 1, 1, 0. 0, 1, 0, 1, 0, 1, 1, 0. That's it. Which of the following is an optical storage devices? To make this simpler, optical basically means light. Which of these use light? The DVD. It's basically like a CD. Not exactly, but it's close. What is meant by the term embedded system? Knowing the definition of an embedded system can help with identifying embedded systems, like in that one question previously. The part of the operation that specifies which operation by the CPU will perform. No, this is something else completely. This is just the machine code. This is also false. This is true. Computerized system that uses a microprocessor to perform one or more dedicated functions, usually part of a larger system or device. Basically, all it's saying is that it uses a processor and a bunch of other things only to perform one specific task, or like one main specific task, which is why your computer isn't considered an embedded system. It performs general tasks. What is the hexadecimal equivalence of the binary number 11001110? You are given this and you want to convert it to binary, or you want to convert it to hexadecimal. Like I said, you can either memorize each value or you can just convert. But one important thing to do is when dealing with these types of questions, split them into groups of 4 and always start from the right. So we have 0, 1, 1, 1, 0, 0, 1, 1. Notice how we have only 2 groups, or notice how we only have 2 nibbles, which is, by the way, 4 bits. A nibble is 4 bits. This implies 3 nibbles, so this instantly eliminate this option. I suggest individually converting each to binary then hexadecimal, but if you can memorize. This basically is 1, 2, 4, 8, 8 plus 4, that's 12, and 12 is C. This one is the 8th bit, the 4th bit, and the 2nd bit are activated, so 8 plus 4 plus 2. This is equal to 14, which is equal to E. My apologies. E, which gives you this. CE is the number we're looking for. What is the binary equivalence of the binary number 10101010? First, copy down the number. Once you have it copied down, you can then assign each bit to the proper value of 2, or to the power of x, let's say. This is 2 to the power of 0, to the power of 1, and then so on. This represents 2, this represents 8, this represents 32, and this represents 128. And you add everything up, all activated bits up. So 128 plus 32 plus 8 plus 2. This simplifies into 160 plus 10, which further simplifies into 170. So you choose 170. Shifting binary numbers to the left is the same as multiplying the binary number by 2. However, it is important to note that if a 1 is truncated, aka a 1 disappears, and then you're no longer multiplying that number or dividing that number if it's a right logical shift by 2. What is the hexadecimal equivalence of the binary number 2752? Unlike binary, there's only really one way, which is the division method. So you take 2752 and divide it by 16. What number, when multiplied by 16, will allow, when dividing 2752 and 16, you get 172. You get exactly 172. So 2752. Subtract both of those, you get 0. Then you continue on. What number, when multiplied by 160, or when multiplied by 16, will get you the closest possible result to 172? 10. 10 multiplied by 160 is 10 multiplied by 16 is 160. Put 160 down here, subtract, you get 12. Now, similar to binary, you start from here, and when starting from here, you write right to left. So you write 0, 12, 10. But this is hexadecimal. Hexadecimal doesn't have 10 or 12, so you need to convert it to the proper letter. And 10 is represented by the letter A in hexadecimal, and 12 is represented by the letter E, and 0 is just 0. So the answer is AC0. All of the following is true about an SISP, except it does not stand for the Internet Supply Program. It stands for Internet Service Provider. It does assign an IP address to its user, and it sometimes may provide them with an email account. It also allows people to obtain an internet connection, and it does monitor internet usage sometimes. Usually most internet service providers do connect or do monitor your usage. Okay, this one you need to memorize the von Neumann architecture. The program counter holds the address of the next instruction to be fetched. Yes. After this, it's supposed to be copied into the memory address register. The address held in the program counter register is copied to the memory address register, then using the address bus. And then it sends a signal to the address stored in the MAR to get the data inside that register. And so the instruction is then copied from the address held in the memory address and is then placed in the memory data register. Then whatever's in the MDR gets put into the CIR, or the current instruction register, and the value contained in the program counter is then incremented so that it points to the subsequent instruction or the next instruction to be fetched. Finally, it's decoded, then executed. Virtual memory is when the operating system temporarily uses memory on a storage device to act as RAM, or primary storage. This is memorization. Printing shopping receipts or shop's inventory. You usually use a dot matrix printer. Think of it as the receipt you get from, let's say, going shopping. You'll usually notice it's kind of low quality. This is a dot matrix printer. Printing prototypes for small-scale products. This is obviously a 3D printer. Printing pictures and photographs is inkjet, and printing high volumes is is laser printer. Why you choose laser printer for this is because laser printers work faster. Convert the hexadecimal number 82116 to denary. Take this number and split it into its constituents: 10, 2, and 1, and the ASN. Take each like small thing as 16 to the power of something. So 16 to the power of 0 here, 16 to the power of 1 here, 16 to the power of 2 here. So multiply by 16 to the power of 2 here, add this to that and multiply by 16, and this one by 1, which is 1. You don't need to do anything really. 16 squared basically 256. This one you can either memorize or work it out in your head, but I suggest memorizing. 16 times 2, that's 32, plus 1. 256 times 10, you'll get 250. 2560 plus 33, you get 3, 9, 5, 2, or 2593, which is the final answer. 2593. But this one you basically memorize. Binary is base 2 because it's represented by 2 digits, 1 and 0. Denary, the basic counting system, is represented from 0 to 9, which is 10. It's base 10 because it uses 10 digits. Hexadecimal is base 16 because not only does it use the basic 0 to 9, but it also adds A to F, so that adds 16 digits. This one you kind of need to memorize what each one is, but to put simply, standard ASCII is represented by 2 to the power of 7 bits, and it only represents the English language, so you can put standard ASCII here. However, extended ASCII supports more Western characters, like, I forgot how to pronounce these, so just forget about that. This is just extended ASCII. However, Unicode supports multiple languages like Chinese, Arabic, Cyrillic. Unicode is basically the most commonly used one in today's world because it represents a lot of languages. The recording of a sound is known as a sample. The conversion of a sound from analog to digital is known as sampling, and the number of sound samples recorded each second is known as sample rate. This one is, once again, memorization. The sampling of an image is the number of bits used to represent a color in the image. Instantly, color and bits. That's color depth. What is the number of colors in an image that have a 7-bit color depth? To find how many colors a certain amount of bits of color depth can represent, all you really need to do is 2 to the power of bits given, or 7. This one you can memorize 128. So 7 bits can represent 128 colors. This one, it's working in reverse. You're given the amount of colors something can represent, and you need to find the bits represented for color depth. So take 1024 equals 2 to the power of x. You can either just find you can either just find x by guessing, or you can use logarithmic, which is basically log 2 1024 is equal to x, and x is equal to 10. But I do suggest memorizing, because if you don't know what logarithm is, then you'll need to use the calculator, but calculators aren't allowed, so I suggest substituting until you get it. Conversions is a pretty important part of the exam. How I memorize each place of it, I suggest memorizing this little thing. KMG TPE, where anything moving this way divide by 2 to the power of 10, and anything moving this way multiply by 2 to the power of 10. Knowing this, you can solve this. 30 megabytes is larger than 20 gigabytes. You'd want it to share a similar digit, or like you want to share a similar size. So maybe megabytes and gigabytes. And moving from MB to mebi, you need to multiply by 2 to the power of 10. So 30 MIB. We put a line here to represent either larger or greater than, and 20 times 2 to the power of 10 MIB. Without a doubt, this is false. 30 MIB is less than, so choose this as false. 5,600 kibibytes is larger than 5 mebibytes. This one you also want a similar unit. You'd want the exact unit. So if you want to move, let's say, mebibytes to kibibytes, multiply by 10^10. So 5,600 kibibytes. Line to represent larger than or less than 5 times 2^10 kibibytes. Now this is kind of hard to do it visually, so I suggest just solving for it. 5 times 1024. Doing the calculations, you get 5120 kibibytes and 5,600 kibi. Looking at this, 5,600 kibibytes is indeed larger than 5,120 kibibytes. So therefore, this statement is indeed true. 40,000 mebibytes is less than 40 gigabytes. This one, once again, you move back. Let's just represent it as, I'll just represent it as to the power of 10 because I don't want to write all that zeros. MIB is either less than or greater than 40 times 2 to the power of 10 MIB. Same reason. Gigabytes to megabytes multiplied by 2 to the power of 10. This is 40,000 times 1024, which you get 4,060 megabytes. And this was 40,000 megabytes. Looking at this, you can say that this indeed is true. It is less than 1 terabyte. 1 terabyte is equal to 1,000 kilobytes. Let me just, in this way you multiply by 2 to the power of 10. So take one, so this 2 to the power of 10 GIB and 1,000 GIB. This is 1,024 gigabytes and 1,000 gigabytes. This is not equal to that, so this is false. To something a file means to change the file structure to reduce its size. This one is kind of memorization, to compress the file. The something is a chip that plugs on the computer's motherboard and acts as the brain of a computer. Brain, CPU, central processing unit. Something is a memory location used by the CPU while processing. It temporarily holds data and instructions. This is a register, as if you remember in the von Neumann architecture, we used the memory data register and memory address registers, CIR, to temporarily hold things. So a register is a memory location used by the CPU. Something is a hair-thin communication path used to connect the internal component of the CPU. A bus. And there's 3 different types of buses: control bus, data bus, and address bus. For the CPU to process an instruction, it passes through a cycle containing 3 stages. Name the stages in this cycle. It's basically fetch, decode, execute. This you have to memorize, along with the von Neumann architecture. Decode, execute. 3 factors affect the performance of the CPU. The number of cores, as in, think of cores as mini CPUs inside the CPUs. If you have more cores, your CPU is more likely to run faster, of course, to an extent. The cache size, which is basically like a mini memory inside the CPU, which can be used to directly access memory, and the clock speed, which controls how fast the CPU works. A computer processor can run a computer program only in the form of machine code, machine code. Something refers to the instructions used to fetch memory addresses for retrieval or storage. Fetching memory implies that data is moving. If data is moving, that means data is being transferred. So data transfer instructions is this one. This refers to the instructions responsible for operations such as addition and subtraction, as well as instructions responsible for comparisons and making decisions. These types of decisions are kind of logical decisions, and this is arithmetic. So obviously, arithmetic and logic instructions. And by process of elimination or whatever, you can fill in the last one with control of flow instructions. These instructions are used to find what's the next instruction to execute. A bit is either a 0 or a 1, and 1 byte is 8 bits. A label consists of 4 bits, and a word consists of 16 bits. The 8-bit number blank will be obtained when we shift 100111101 to the left. All you really have to do here is move each bit to the left once. So 0, 0, 1, 1, 1, 0, 1. We have 7 bits, we need to fill it up, so we need a 0 here. Meaning the 8-bit binary number 00111010 will be achieved. Convert the following binary number -110 into 8 bits 2's complement. This one, there's two ways about going about this, but one method is heavily reliant on guessing, so I don't think I'll be using it. First, what you want to do is take the absolute value of -100 and -110. So absolute value of -110 base 10 gives you 110 base 10. Then you just convert it to binary regularly. Once you get the absolute value of 110, you need to convert it into binary regularly. 128 is too large to be subtracted from 110, so you put 0 here. However, 64, you can perfectly do that. It's perfect. Just subtract 110 and 64. You get 46. 46 can be subtracted from 32 can be subtracted from 46. You can subtract 8, subtract 4, and subtract 2, but you can't subtract 1. After this step, you could invert each of the bits. So basically 0 becomes 1 and 1 becomes 0. And finally, you add by 1. This line is to show that you do not add these. You don't add this. So 1 and 0, 0, add 1, and then you just write everything else as the same because there's nothing else to be added. So finally, get the answer 100, 100, 10 as 2's complement. This is an example of a MAC address. You can tell this is a MAC address because it consists of 12 hexadecimal digits. This, which I'm not going to read all of that, is an example of an IPv6 address. This is an example of an IPv4. Something is a language that uses tags to create web pages. This one you should remember from previous year's HTML. Hashtag B18904 is an example of color codes. These codes are usually used in HTML as it says here. 0x3041408 is an example of an error code. You can also tell this is an error code because it's the final option we haven't used. When two 8-bit binary numbers are added and the result is larger than what? To find what goes in here, you can either just memorize it as 255, or you can find it via math. To find what the number must be larger than, all you really have to do is take whatever is here. Let's say this is n. Take 2 to the power of n, subtract all of that from 1. And here we're given 2 to the power of 8. 2 to the power of 8 minus 1. This is equal to 256 minus 1, which is equal to 255. Therefore, if the number is larger than 255, an overflow error will occur. Computers understand and process data in the binary format. This question usually never comes. So it turns out I ended up solving this question wrong in the quiz, so I'll just properly show you how to do it. First, you take 32 megabytes, convert it into megabytes by doing 32 over 8.38. You get that as a fraction. I suggest doing it as a fraction because when you do it as a decimal, you get inaccuracies sometimes. You get 1600 over 419. which is the number of MIB per second. To get 80 MIB per second, you just need to multiply 1600 over 419 by x. So for x, you should end up getting approximately 20. X should approximately be 20. For more accuracy, I do suggest looking at converting 32 megabytes to megabytes using like an online converter. A security system records videos. 1 minute of video recording requires 64 megabytes of storage. Calculate how much storage would be needed for 8 hours of video recording. These types of questions, I suggest factorizing numbers. But for now, don't worry about factorizing. Just write out everything given. 1 minute is equal to 64 megabytes. And in minutes, 8 hours is 480 minutes. However, you'll get this answer in megabytes. You want it in gigabytes. And you know that megabytes to gigabytes you need to divide by 2 to the power of 10. You can represent 64 as 2 to the power of 6 over 480 over 2 to the power of 10. Using the identities of exponents, you can then say that 480 over 2 to the power of 4 is our answer. You can further make this simpler on you by factorizing 480. After doing all of that, after factorizing 480, you should get 2 to the power of 5 times 5 times 3 over 2 to the power of 4. And because of the identities of exponents, you can do 5 minus 4, you should get 2 times 5 times 3. To check this answer, you can plug it into the and after this, you should get 30 gigabytes. You can check this answer by plugging it into your calculator, and you do indeed get 30 gigabytes. An image is 512 pixels high and 320 pixels wide with a 24-bit color depth. Calculate the file size of the image, give your answers in kilobytes. Usually when you calculate the file size of something, you're going to get the answer in bits. To convert it to get from bits to bytes, you need to divide by 8 times 2 to the power of 10. You say this because bits to bytes, you need to divide by 8, and from bytes to kilobytes, you need to divide by 2 to the power of 10. So put everything in the given here. 512, which you can just instantly say that it's 2 to the power of 9 times 320 times 24 over 8, because we want it in because first this will give it to us in bytes, and then 2 to the power of 10, because this will give it to us in kilobytes. Using the identities of exponents, this can be simplified into this. Cancel this, you get 1. Cancel this, you get 3. Once again, cancel this, you get 1. Cancel this, and you get 160. All you need to do now is multiply 160 by 3, which should give you 480. You can then plug this equation into the calculator. 512 times 320 times 24 divided by 8 divided by 1024. You do indeed get 480 kilobytes. The two parts. This one is purely memorization. The control unit manages the flow of data, used to carry out shifting operations on data. This is a type of arithmetic operation, which is the response of the ALU. Carries out arithmetic operations, obviously instantly arithmetic. Carries out operations such as AND or NOT. We'll take this later in computer science, but these are like logic gates. And from the name, logic gates at ALU. Manages the execution of each instruction. This is the control unit. It's controlling everything. It's managing the execution. Synchronizes the working of memory processor and input-output using a system clock. This is the control unit. It synchronizes. It controls mostly everything. Fetches each instruction in turn. Control unit. Sends signals to other components telling them what to do. control unit. This question is purely memorization, once again. Temporarily stores data being processed on the results of the calculations performed by the ALU. That's the job of the accumulator. Contains the instructions to be decoded and executed. That's the program counter. It addresses arrays of data and participates in some arithmetic operation in the calculation of storage addresses. This is the job of the index register. So the address of the next instruction to be executed, it gets incremented after the current instruction is executed. This is the job of the program counter. So it's the address of the memory location of the data to be accessed. This is the MAR. Contains the instruction to be decoded and executed. That's the current instruction register. Data being fetched or copied, memory data register. Carries memory addresses between processor and memory. This, just from the name, address bus. Used to exchange data between the processor, memory, and input and output devices. Data bus. Carry signal from the control units. Control bus. A CPU may be made up of one or more processing units called cores. This is true. A CPU having 2 cores is called a tricore. This is false. A CPU having 2 cores is called a dual core or bicore, usually dual core. So false. A CPU having 4 cores is called a quad core. This is true. A CPU having less cores will be able to run several programs in parallel. This is false. The more cores it has, the more it's able to run several programs in parallel. Doubling the number of cores doubles the speed of the CPU. No, and here's the reason why. Let's take these two CPUs. Let's call this CPU A and CPU B. CPU A is single core. CPU B is dual core. Theoretically speaking, B should be twice as fast as A. However, this is false, because the cores still need to communicate with one another. This will cause it to be a bit slower than exactly twice. So B is still faster than A, but it's just not exactly twice the speed. Some of the speed of the CPU may be wasted on communication between the cores. This, as I explained, is true. The cache is a small size, high-speed random access memory that is built inside the CPU. This is true. It permanently stores data, and it permanently stores instructions and data that the CPU is likely to use. This is false. It does not permanently store anything. Fetching instructions and data from the cache is faster than fetching them from the RAM. This is true. The smaller the size of the memory, the more data instructions that can be stored in it, and the faster the CPU. This is false. It should be larger, the memory, not the smaller.